Alright, so here's another tutorial, and this one is going to be about how we can avoid flight delays. So if you open it up, it should be called Avoiding Flight Delays, something along those lines. Pretty much anything to do with a flight, probably the right, the right document. And so I just want to go through these really quick. So ID over here, it's not highlighted. There it is. ID is going to refer to just that, the ID. So a unique identifier. Month is the month, day is the day. Day of week refers to which day of the week it was. Airline, origin airport, destination airport. Scheduled depart group and departure time group are kind of the same thing. It's just saying that it was scheduled to depart in the morning and it actually departed in the morning. The departure delay, so how long did it take to delay and how much later that actually was. The scheduled time for the flight, the actual elapsed time. So how many minutes in the air versus how many minutes scheduled in the air versus how many actual minutes in the air. Scheduled arrival time group, when they were scheduled to arrive, morning, afternoon, evening. When they actually arrived, morning, afternoon, evening. The arrival delay, if it's negative, that means they arrived early. If it's positive, that means they arrived late. So this is a really important column for us. We can kind of just ignore diverted or canceled. And then with these things, these are potential causes of the delay. So was it because of the air system? Was it because of security? Was it the airline? Was it a late aircraft? Was it weather? Where is the delay coming from? So that's only in the case where arrival delay is a positive number, and then it can actually determine where that deal is. Alright, so let's start building. First off, I want to create a column that only counts those calculates all of those that have a delay of arrival of above 15 minutes. So, delayed arrival, because we don't want to arrive 15 minutes late. That's like just too much, right? So if our arrival delay is greater than 15, 1, else 0. Good deal. Alright, so then I always like to start with building cards. So I want a sum of the delayed arrival over 15. So there's 663 flights that were delayed over 15 minutes. And I'm going to give it a title. Delayed flights. Alright, and then let's do another card. That's going to be our total number of flights. So let's do ID. And yep, that's just going to be a count. And same, I'm going to turn off the category label, turn on the title, and do total flights. And then another card, because I want to see how many flights delayed are we having compared to our total flights. So I'm going to do here, actually, I'm going to create a calculated column, or new measure, sorry. And so this is going to be a delayed over total, which is equal to the sum of our delayed over 15 divided by the count of our ID. Alright, and I'm going to put that delayed over total here. Alright, so about 13% of our flights are being delayed. Then I like these to all obviously be same size, but just a bit smaller. And then let's change the title on this, get rid of category label. Awesome. Alright, so we have at least a decent idea of what's going on. 13% of our flights are being delayed. So if I'm flying, I want to figure out what airline I should fly with. What airline is having the worst, the highest delays. So let's make a matrices. And we're going to put airline in our rows. And then for our values, I want account of ID. I want delayed arrival. And I want to see a delayed over total. Alright, so, and let's make all of, I'm going to make these thinner so I can squish them further. Let's do 200. And we'll make this bigger and up those values so that we can see. So make those size 10. Yellow, let's do 12. And then row headers also, oh wait, no, I want this for 12. And column headers also 12. Good. Alright, so we're seeing that we probably don't want to fly with Atlantic Southeast. They have a pretty dang high delay. And then also Frontier Airlines has a high delay. However, like everything else, 15%'s kind of pushing it. Delta seems to be really good about keeping it low. And they also have the highest number of flights. So let's also look at our destinations. So something I really love about Power BI, and Tableau has the same feature, but I am not using Tableau, so is the map function. And so if we pull up a map, and I put in destination airport, location, destination, and that, let's see if I can pull over arrival airport to origin airport, that's what it's called. Meh. We'll see how those are impacting. And let's do size based on how high our delayed over total is. And then we can do saturation based on the ID. Alright, make that nice and big. See if I can like zoom in a little bit maybe. Kind of hard because we have Florida and Seattle. Anyway, you get the point. So, delayed Denver tends to give us the most delays. And then, yeah, these smaller ones, Boise, pretty dang good. Good to fly to Boise. Alright, so let's do the same thing. But this time, let's use arrival or origin airport. Alright, so I had to cut down this data set a ton because it was huge. And because of that, it's there's only like a couple cities that it shows. I'm gonna make. But anyway, you get the picture. So yeah, we can kind of see that from origin airport, Seattle has a pretty high number of delays along with Wisconsin, except there's only 17 flying out of Wisconsin. So yeah, the majority of our flights are flying out of Salt Lake, and it looks like Salt Lake tends to have a pretty low delay. Alright, next, let's make a nice bar chart. So, on this bar chart, let's look at how the values, let's do it by departure time group. Actually, let's do, departure time group, because that's going to interact it more. We want that on the axes. And then let's look at how the impact of all the different type of delays impact it. So we want weather, we want security, we want late aircraft, air system, and airline. Alright, make that semi-big. Maybe if I make both of these a bit skinnier, we can fit something else in there. Yeah. Alright, so we can kind of see that it looks like late aircraft leads to the greatest delay, with totaling over 6,000 minutes, about 7,000 minutes it looks like in delays. Well, 6,781 delays. Minutes in delay, not that many delays. And comparatively, next, and that specifically is common in the evening. And if you want, you can just click on one of these, and it doesn't really change anything, but in an ideal world it would. Last, let's look at how maybe the day of the week impacts those. So let's do a stacked bar chart. Did that in the wrong place. Let's do a stacked bar chart, so one of these. And then let's look at how day of the week. So once this is going to do a weird thing where it organizes the day of week alphabetically instead of by the actual day of the week. And then for values, let's pull over ID, so the total number of flights. So it looks like Saturday, Sunday, and Thursday are those days with the most flights. Oh, actually, Sunday, Thursday, and Wednesday. Interesting. And then let's also look at how that impacts the delayed over flight. That doesn't work. Delayed over total. So you can hover over it and see. Alright, 11%, 15% delay on Wednesdays. Yeah. So, not really telling us much there. But let's add delayed arrival over 15. We can kind of see how many flights are being delayed compared to that total number of flights. And that's about it for the amount of time that we have. I'm just gonna let's make these a bit wider. Alright, and then let's do, I like these to all be like a cute little color. I think it's nice. So they do have to be a little shorter. Shoot. So let's do general. Let's make the height 120. And then let's do a background color on, and let's make it blue with the title being white. Alright, so that is a rough tutorial on how we use this data to find what is causing delays, and maybe where we should fly and where we should fly out of in order to avoid those delays, along with what day we should fly on. Alright, and that's it. Thanks.